Today's video lesson will be on section 5.4, the fundamental theorem of calculus. I hope you will enjoy this lesson today. The first thing we'll have is sine of x cubed as a quick review. This is the same as sine as x quantity cubed. So derivative of sine is cosine of x cubed times its derivative, 3x squared. For the second one, we have to bring down the power. This is chain rule. Leave what's inside parentheses alone. Subtract 1 from the power times the derivative of what's inside. And that's it for that one. Checking the answers. There's the first one, dy dx, and there's the second one. Okay, next set of problems. Derivative of the first, we'll use the for 6. Quotient rule, u over v. So we have v times derivative of u minus u times derivative of v all over v squared. Negative times negative is positive. That's our answer. 7. It's parametric, so dy dx equals dy dt over dx dt. Derivative of y is cosine. Derivative of x is 2. And that's it for those. Here's our first answer. There's our second answer. Please excuse the coughing during the video. On to the fundamental theorem. We're just going to look at one part today, and the other part we'll look at tomorrow. So we already talked about a definite integral represents accumulated change. And an example, the integral from a to b of v of t dt gives the distance a car traveled between a and b. So this is exactly how we're going to find the distance traveled by integrating from a to b the velocity v of t function. So definite integrals have boundaries. Their answers are not functions, they are number or values. Fundamental theorem of calculus tells us if a function is continuous on the interval from a to b, then the function f of x equals the integral from a to b of f of t dt and has a derivative at every point of x in the interval from a to b. And here's the big rule. The derivative of the integral gives us back the function. So think about that. Integral is antiderivative. If I take a derivative of an antiderivative, I'm back with what I started with. It doesn't matter what the bottom piece is. This is a little bit hard to read, so I'll rewrite it a little bigger for you. So this is the derivative of the integral from any number to x. A is any number of some function with respect to t, gives us back the same function with respect to x. A can be anything, any number. Doesn't matter what it is. The one piece of this you have to remember, if this isn't just an x, you're going to multiply by its derivative, or you can just always multiply by a derivative. Derivative of x is 1, so this would be like saying times 1. If you just don't remember it that way, you can't. So, fundamental theorem part 1, every continuous function is the derivative of some other function. Every continuous function has an antiderivative. So the process of integration and differentiation are found to be inverses of one another. They have a direct connection. So here's some examples. The derivative of the integral from 0 to x is the function with respect to x. So my answer is 1 over 1 plus x squared. Again, times the derivative of the top piece. This is 1. I'm just going to write it like that. So my answer is that. Okay, another notation. So that's the first way it can be written. Second way is just written like this, with an integral as y equals find dy dx. It's asking the same question as the first one. So how does this work? Oh, look, it's x to 1, not 1 to x. So what do we need to do? We're going to apply the rule from yesterday. Take the opposite from 1 to x, because the definition of the fundamental theorem says it has to be any number a to x. We don't want x to a. That's wrong. So this would be like this, and that will equal negative 1 over x. We replace t with x by definition using the fundamental theorem of calculus. That's the answer. Okay, another example. Find dy dx. Here's the function with an integral. And so what we're going to simply replace t with x times, oh looky, it's not just an x this time, it's a 2x. So any number in the bottom, remember, doesn't affect the answer whatsoever. So my answer, dy dx. Derivative of the integral from 1 to 2x of cosine of t dt equals, replace the t with an x. You actually aren't taking a derivative of what's in there or an antiderivative, because it's just, again, they're like inverse operations. Kind of like the idea the derivative and integral cancel each other out, but not quite that way. In place of the t, I have to replace it with not just an x, be careful here, I have to replace it with a 2x. Whatever is up above here goes in place of that. Doesn't matter how many places you see t, you got to put that value in, times the derivative of 2x, 2. And so this is my answer right here. Next one, find the derivative of the integral from sine of x to cosine of x of t squared dt. So this one looks tricky because there's no number. So what do we have to do? We're going to use creatively the additivity rule. So any number can be any number, so here's how we want to do this. So I want to get sine to cosine, so we got to figure out how this is going to work using additivity. Sine of x to cosine of x. So I want to be able to do this rule. And we can start by using, remember we have to have a number to x, but here's how this would kind of look to start with. Sine of x to, we'll pick 1 just for fun, then 1 to cosine. So additivity, sine to 1 plus 1 to cosine will give me sine to cosine. Oh, but looky, this one is wrong. This has to be switched around. So put a negative in front. There's another rule, 1 to sine of x of the t squared plus integral from 1 to cosine of t squared dt. So how are we going to solve this? We're going to plug in place of t, sine of x. So remember the negative. So negative sine of x squared times its derivative, because it's not just an x on the top there. Derivative of sine is cosine, plus we place cosine of x in for t over here. So cosine of x squared times its derivative, which is negative sine of x. And that's our lovely answer. If you want written notation, remember that's calculator style notation. You would put the 2 right next to the sine and the little 2 over in cosine right next to that. So it would look like this. Write it down below here. Sine squared x cosine x plus cosine squared x times sine of x equals that. And that's it. This is just an activity, not on your note sheets, regarding using f and I and t. I already showed you how to solve for f and I and t. I explained how to numerically solve this. Is graphing numerical derivative using a value. So you can look at this if you like. We're not going to formally go over this in class though. That's it for part 1. Our next exciting part 2 will come on Thursday. Have a great day, everyone. I'll hope to see you on Thursday.